the previous videos, we mentioned about the detailings of the beams and slabs. For you to prepare the detailings for the beam and slab, you will need to refer to geostructural key plans, and you should name the members properly so that it can easily be traced from the structural key plan. There will be indications in terms of the size and dimensions of the member, as well as the reinforcement and shear links provided in the members. Other than that, when they are lapping, it should be clearly indicated, and the grid line and dimensions should also be in accordance to the structural key plan. In these videos, we're going to proceed with discussions with the columns. In fact, we have shown the detailings for the columns, which is in terms of the column schedule, quite a number of times in the previous videos. In these videos, we're going to explain it in more detailed manner from the start to the end until you have the column schedule completed. These are the informations that will be provided related to the detailings of the columns. You will need to clearly indicate the column names, present the column schedules, indicating the amount of reinforcement bar and link, and also indicate the lapping within the columns. Without further ado, let us get started. In order for you to produce the column, first you will need to refer to the structural key plan. As you know that the columns are actually connecting different levels of buildings, that means it is actually passing through various levels of the structural key plans. It should be reflected in the foundation key plan, the ground floor key plan, the first floor key plan, and so on and so forth. Remember, in every floor, the names of the columns needs to be clearly indicated. It is so that you don't have to flip through different levels of the key plan in order to recognize which column is meant for what. This is a typical foundation key plan. What we see here, there are a series of the foundations. There will be proposed foundation size, the numbers of piles, and the columns it will be indicated. The key plane here do not provide the numbers of the columns. However, it is always good of you provide the numbers of the column. It is so that when the contractors are building the foundations, they also need to know about the size of the column, as they need to provide the starter bar extended from the foundations to be embedded in the stump of the columns. Other than providing the numbers for the foundations, you should also provide the numbers of the columns. And then you come to the ground floor, where you see a series of columns are provided. There will be column extended through the ground floor key plan going up to the next story, while there are columns actually not going up to the next story. In fact, you need to design every single columns. And for the common design, in terms of the size as well as in terms of the area of reinforcement bar, that the capacity of the column can be classified into several groups in order to limit the variety of the column design throughout the entire building. This is what you can do. First, you analyze the load acting on each column. Based on the loads you analyze, you classify them in accordance to a range. Maybe you put them in the ascending orders, and then decide how many classifications of the columns that you're going to have, and classify accordingly. And then within the classifications, you see if the columns are of the similar size, which may require you to further classify the columns. From there, you can more or less conclude an appropriate numbers of the columns to be used in the building. Now you do some numbering. C are normally used to represent the columns, and then C1, C2, C3, and so on and so forth. Once you have those columns classified, then you design and provide the reinforcement bar. This is one of the way, or you can design every single column in the structures, of course with the help of the Excel spreadsheet. Then you observe the amount of reinforcement bar, as well as observe the shape of the columns in terms of the size and dimensions, and make necessary classifications that the amount of reinforcement bar which are close are to be rounded up, so that you have the chances to provide additional reinforcement bar instead of reducing the amount of reinforcement bar. When you do the classifications, the safest approach is for you to round the amount of reinforcement bar so that the design becomes more conservative. It is not for you to round down the amount of reinforcement bar that you make it more economical. This is to prevent sometimes you overlook something that can bring you into a situation that you under-design the section. Now that you have classified the column, you need to arrange them in the column schedule. This is a typical column schedule. There will be the names of the columns, normally labeled as C1, C2, C3, and so on and so forth. There will also be height of the columns, normally defined by the foundation level, stump level, ground floor level, first floor level, second floor, and to the roof. There will be a diagram here to indicate the lapping length of the reinforcement bar within the column, especially when you know that the columns are constructed level by level. And there will be illustrations in terms of the amount of reinforcement bar to be provided in the columns, indicate how many reinforcement bar there, as well as the shellings that are used to tie the reinforcement bar. And there will also be the details in terms of the text, writing the amount of reinforcement bar as well as the size of the columns. Let us look into it one by one. First, the number here needs to be in line with the structural keyplane at every single story. This needs to be consistent throughout. Remember to provide the name for every single story so that the contractor do not have to flip here and there, searching between different structural keyplane in order to know which column it is. Now let us look at the reinforcement bar in terms of the lapping length. We will zoom into it and you will see the different levels. The levels start from the soffit of the power caps, the top surface of the power caps, the ground floor level, the perimeter fencing. This one is an special case, which normally this doesn't appear here. Most likely you have ground floor level, and then straight away you go for the first floor level, and then to the second floor level. This one is added because there are design of the perimeter fencing, which is considered as a part of the structures of the building. And the perimeter fencing, there are columns which are also properly designed. Then we have an additional level. As far as the typical project concern, you can simply ignore this part. That means you will go straight from the ground floor to the first floor. And then what it is indicated here, you have the reinforcement bar within the power caps, and then you have the reinforcement bar to be lapping within the power caps, and this will be extended throughout the stump and then go up by at least 600 mm from the ground floor level. Typically the stump is not that tall, somewhere around 1.5 meters. Sometimes it can be shorter than that. And then the reinforcement bar from the ground floor level, it will go up straight into the first floor level, and there will be bar extruded from the first floor level to be lapped with the subsequent column in the first floor level by at least 600 mm. This process should proceed until to the second floor level until it ends at the roof level. This is about the lapping of the reinforcement bar in the columns. Now you will see the illustrations of the columns in the column schedules, as well as the dimensions and details in the columns. Based on the illustration here, you know that 4 units of T25 will be provided. The rebar, it will be R10 300s. We mentioned about R10 is also not quite common in the industry. Probably you can reduce the size by having the rebar spacings to be more closely placed, which can be R8, 200 or 175. And then the dimensions of the columns is indicated, which here indicates that it is 300s times 300s, and this one is 450 times 300s. You will need to demonstrate the reinforcement bar, how it is being laid within the section. This is 4T25, this is 8T25. There will be inner ties. It is normally required when you have the reinforcement bar placed at the intermediate of the columns. It helps to keep the reinforcement bar in positions during casting of the columns. We shall demonstrate the other design. The amount of reinforcement bar may be different. The size of the reinforcement bar may also be different. Sometimes you encounter quite an awkward size and shapes. This is most likely it is due to the architectural drawing, that some of the column is meant for the aesthetic purpose, and some of the columns are quite special due to the some limitations from the considerations of the architect. We will proceed with the further demonstrations. For some critical column, the amount of reinforcement bar may be extremely large. Where you have so many reinforcement bar, this you should double check it, whether your calculations is correct or not. If you observe very significant difference in terms of the amount of reinforcement bar, even though the size of the sections are similar, you should go back and do proper checking again if there is any mistake in your calculations. There must be a reason for that, which if you confirm the design is correctly done, then you have no choice, unless you would like to revise your structural key plan to have the column more equally spaced, so that there won't be a significant variations in terms of the loops adding on the column. Sometimes the amount of reinforcement bar increase significantly may not necessarily due to the axial load. You know that the concrete is very good in compression, which can be a part of the resistance to the compression load. It is very often that because of the bending moment as well as the slenderness of the column, the amount of reinforcement bar increased significantly. Most likely this is going to be a columns at the corners where you have double axis bending within the column, or it is also possible that it is at the side of the building where there will be bending moment in one single axis. This will lead to a situation that relatively large amount of reinforcement bar will be required. You will need to be careful with the provisions of the shelling for the column. Normally, we would like the link at every corner here to have one reinforcement bar. Let's say now for these shapes, even you calculated, only 4 reinforcement bar is required. However, this is not achievable by 4 units of T12 reinforcement bar. You cannot simply put 1, 2, 3, and 4 or any 4 out of 5 corners here, as you are unable to maintain the shapes. Based on the shape here, the reinforcement bar provided, you need to be at every corners of the side of the columns, which in this case 6 reinforcement bar will be required. However, based on the pathway of your link, you will require additional 2 reinforcement bar. Let's make this column to have a minimum of 8 units of reinforcement bar. This is one of the considerations. And if your column is relatively big, even though through your calculation only 4 reinforcement bar is required, you cannot just simply put the 4 reinforcement bar at the corners. You need to consider for the potential problem with the surface cracking. Most likely you're going to add in additional reinforcement bar here in order to control the surface cracking. In fact, you need to design for the surface cracking in accordance to the standard. But simple rule of thumb, you need to maintain it within the clear spacing of less than 300 mm in terms of the reinforcement bar. At least from here, you will know that the surface cracking is not a concern to the structure. Next, you will need to refer to the structural keyplane for every floor to determine whether the illustrations are provided at their respective floors. There are columns stopped at the stump level. There are also columns stopping at the ground floor level. There are also columns went throughout the building from the foundations to the roof floor. All these need to be clearly indicated. You see some text here. It is stated that follow the top column. That means the details here at every single story here, it will be identical to the one on top. That means the same detail will be applied throughout the building. Sometimes you might need to provide some notes there as a part of the disclaimer, advising the contractor to check the floor plan carefully, just in case there are any mistakes. For example, the column mark for individual column might terminate at certain floor, and your column schedules are typically produced in a generic manner, which may not fully taken into considerations in terms of the orientations of the columns. This you need to make known to the contractor, such as refers to the key plan for the column marks and exact positions, as well as the orientations of the columns. That means the columns, if you show in this arrangement, it may not necessarily always in the vertical arrangement, especially in the key plan. Sometimes it may appear to be horizontal arrangement. Also, sometimes you have a situation that smaller column size go upward, while a bigger column size remains at the lower floor. This one you need the contractor to check it carefully in terms of the alignment of these columns that's going up. It can be to this edge, or it can also be at this edge. Sometimes it may also be at the center positions of the column, where you have two sides here not being continued to the next floor. For example, something like this, you need to clearly indicate that the positions of the penetrating columns. This can easily be seen from the structural keyplan. If your column schedule is just meant to show the detailings, which this kind of locations of the columns are not clearly indicated, you should notify to the contractor to avoid any confusions. That's why you are asking the contractors to check the keyplan for the exact positions as well as the orientations of the columns. In fact, you can have different positions of the columns put in different classes in the column schedule, but this will increase the numbers of types of the column in the column schedule. Normally, I would prefer the technical drawing to be as simple as possible, limit the numbers of types of the columns, and regarding the positioning of the columns, we will ask the contractors to observe themselves. Make sure it is made known to the contractors. What you see here, the detailings for the column may look simple, but there are a lot of useful information presented there. There is a high concentration of the information and needs to be comprehensively presented. This is to prevent the ambiguity and confusions by the contractors. You can always ask your another group member to help you to cross-check in order to find your blind spot. If your group member cannot understand, most likely you have to do some improvement in terms of the detailings of the columns.